So on CCNA, our first topics is OSI layer. Okay, before going to the OSI layer, I'll discuss something, another topics. It will help you. So career path and expected salary. Okay, so if we go our career path, so suppose you want to be a network engineer. Okay, so you will do different types of courses and technology like CCNA, CCNP, CCI, and everything. But what type of roles are asking for what technologies? Okay, let's discuss that. So for a network engineer or network administrator, you need to be skilled on CCNA, CCNP, MicroTik, Fortinet, and Juniper knowledge. Okay, so these are mandatory. This is actually a firewall, and CCNA and CCNP. Okay, if you learn these technologies, you will be able to apply for network engineer or network administrator job. Okay, then security or firewall engineer. If you want to be a network firewall or security engineer, okay, then you need to be skilled on these technologies like Fortinet, Palo Alto, Cisco ASA firewall, or Juniper firewall. Before going to that, you must learn the CCNA. Okay, you should have CCNA knowledge. So for a security guy or firewall engineer, you should learn CCNA, Fortinet firewall, Palo Alto firewall, Cisco ASA firewall, Juniper, and also Cisco Firepower Threat Defense, FTD. Okay, so these are the requirements for a security guy or firewall engineer. Then cloud network engineer. Okay, you need to be skilled on VPC, VPN, SD-WAN, cloud security, Kubernetes, and networking basic like CCNA. So CCNA is mandatory for all field. Okay, this is for cloud network engineer. Cloud network, you need something like AWS, Azure, GCP. Okay, but these are the technologies. These are the vendors, but these are the technologies you should learn. And finally, not finally, and next one is data center or core network engineer. Okay, they are highly paid. They are highly paid in the job market. Maybe a CC engineer, CC data center engineer will get maybe mm, uh, 1 lakh, uh, 2,000 dollar per year. Okay, maybe and more. Data center engineer or core network engineer. But you have to be good on Cisco Nexus, Juniper, Arista, Cisco ACI, VXLAN, BGP, OSPF. All these technologies included in CCI data center. CCI data center. Okay. So before going to CCI data center, you should have CCNA and CCNP knowledge. Okay. Then you can move for CCI data center. They are highly paid in the global market. And finally, if you have all types of knowledge, okay, like CCNA, CCNP, cloud, security, all knowledge, then you can be a network architect, like CCNP level, CCI, data center technology, Cisco ACI or SD-WAN, cloud networking, okay, everything, then you will be a network architect. And actually, network architect are highly paid. If you do the job search in LinkedIn as a network architect role, okay, you can check here what they pay. So this salary is actually based on the India or Bangladesh. Okay, they may get 250,000. That means 250,000. Okay, per month. So this is the highest salary in India. Okay, in INR. But in Canada or USA, it will be 10 times than this one. Okay, minimum 10 times. So these are the rules you can achieve after learning this networking technology. So let's move our certification path. Okay, you can say our first certification is this one, CCNA. Cisco has different types of certification. Okay, Cisco certification path. So your first certification is the associate level. So for this one, you don't need to do any exam. Actually, exam starts from here, associate level, CCNA. Okay, then professional level. So simply 10 times harder is professional level. 10 times harder than CCNA is professional level. So in professional level, you have to learn the CCNP technology. Okay, CCNP. If you learn the CCNP, then you can be a network professional. Okay, not associate level, network professional. And as a network professional, you can do configuration in the core level, core infrastructure. And then expert level, which we call CCIE, Cisco Certified Internet Network Expert. Okay, so these guys are highly paid in the job market. And after expert level, you have the architect level. So actually, limited number of person has architect level. So almost 8 or 10, 8 to 10 in USA maybe are CC architect, Cisco certified architect, Cisco certified architect. Only maybe 8 or 10%, because this is the very hardest level. Okay, not easy to pass. But this one you may expert level. So there may be 12,000, 64,000 CCI in the world, maybe 64,000. Okay. So you can, if you can reach this level, expert level, okay, you are very expert, you will be very expert in networking technology, and you will get high salary in the job market. Okay. So please go for the CCI. CCI is the, it is called the PhD of networking. Okay. You can say the PhD of networking is expert level. Okay. Or any CCI. But Cisco has a lot of CCNP section, a lot of CCI. Okay, let's check what are the section of CCNP or CCI. If we can see this, so CCNA, there is only one CCNA in the job market. Or in Cisco certification, they have designed only one CCNA. Okay, only one CCNA. Then in CCNP, you have a lot of track. CCNP data center, CCNP collaboration, CCNP enterprise, CCNP security, then cyber security, CCNP, then CCNP service provider, CCNP wireless, and also CCNP automation. CCNP automation. Okay. Each section, each CCNP has two sections. One is core, another one is concentration. Concentration. There is only one core in each part section, only one core. That means if you do the CCNP enterprise, you have N core, CCNP N core. Okay, N core is must. This is called actually the core technologies. And you can see the multiple concentration part, which means you have to select any one from these topics, any one. Okay, so one exam from the N core, another exam, another elective subject. That means you can choose any one. For example, you have chosen NRC, Advanced Routing Section, NRC. Okay, if you pass these two exams, you will be CCNP Enterprise Certified. CCNP Enterprise Certified. Okay, similar to CCNP Security. You need to pass two exams. One is core exam, another is concentration exam. Core exam, you have to pass S core or security core. This is the core section. And another one, you can pass from first one, for example, SNCF. This is the concentration exam. Okay, you can see a lot of concentration part, but you need to pass only one exam. If you pass this one, it is actually the next generation firewall. SNF means next generation firewall. Okay, if you pass S score and this one, you will be CCNP security certified. Say as like a same as data center, same for this one, this one, this one. Okay, so there are 1, 2, 3, 4, 5, 6, 7, 8, 8 section, 8 separate topics for CCNP. And on each exam, you have to pass 2 exam, right? So normally CCNP enterprise, CCNP security, CCNP data center are mostly demanded. Okay, CCNP security, CCNP enterprise, and CCNP data center. These three are mostly demanded. Also, another one is demanded CCNP automation. Okay, this is actually your programming. Okay, programming in network programming. So you have to pass separate exam. You can see CCNP automation or DevNet. And then again CCI, we have multiple sections. CCI collaboration, CCI data center, CCI enterprise, CCI security, CCI service provider, CCI DevNet, CCI wireless, and CCD. That means you have 8 sections, 8 separate sections on CCI. Okay, you can choose any one. For example, CCI data center, CCI enterprise, and CCI security, they are mostly demanded. And also CCI service provider. Okay, for CCI, you need to pass 2 exams. One is any core. For example, you will be CCI enterprise. Okay, CCI enterprise. Then you need to pass Encore, which is also the part of CCNP enterprise. Okay, you should pass Encore. Encore is a prerequisite. Then you should do a lab on the exam, 8 hours lab section. 8 hours lab section. Okay, this is quite hard. And also the exam is too much costly. For example, for CCI enterprise, you need to pass 2 exams. One is $400, another is $1,600. You need to do boot camp, they actually $200. You need to do training, you also need $200. Okay, actually this is quite a journey. Okay, also it is costly, and also you need to pay 2 to 3 years to achieve CCI certification, because passing rate only 5%. Okay, so CCI is costly and also harder to pass. Okay, that's why there's a limited number of CCI guys in the world as of now. Okay, so these are the certification part. Now, I am going to some topologies. So these are the topologies. For example, this is your company head office, and this is your branch office. Okay, so suppose your company name is Augmeris company. Augmeris or Commure company. Okay, Commure is a USA-based organization. Okay, so Commure has a lot of branch. A head office in Canada, and another office in USA, another office in Australia, England. Okay, you can have a lot of offices. Okay, so you need to connect multiple offices. Actually, each office, we can say it is a LAN, right? Local area network. LAN. This is also a LAN. LAN means local area network. LAN is a network using the device, firewall, router, switch. Okay, these are the components. These are the devices to create a LAN, right? To create a LAN. LAN actually extend over the building or a flat. Okay, local area network or a small network, which represents actually a very small network inside a building or inside a flat. Okay, you can have 3 main devices: firewall, router, or any L3 switch or a router. This is a firewall, and these are the switches. This is also switch. Okay, these are the devices. We can call it the LAN device. Okay, and router or L3 is also a one device, but firewall is not a one device. Okay, router can be one device. One means wide area network, right? wide area network. This is your wide area network. Wide area, you can say the internet. On internet, there are a lot, thousands of or millions of routers, right? Millions of routers. They are interconnected inside the world, right? Or over the world. Suppose USA, UK, Canada, okay, they have their own network. Suppose something like this is your office, this is your another office. They are connected. Okay, and you have a lot of network inside your cities, or campus. Okay, so if we have network inside a campus, we call it the campus area network, right? If we have network inside the city, then we call it the metropolitan area network. Suppose these two networks are inside your campus, like a university, then you call it and these are connected using a code switch. These will be a code switch. Okay, if two networks are connected, but these two network belongs to a university, then you can call it the CAN, or campus area network. But if two networks are distributed over the city or inside the city, okay, then you can call it the metropolitan area network. If you have a lot of network spread it over the world, okay, this network in USA, this one is Canada, this one is another one. Okay, together they can build a one wide area network. Internet is an example of wide area network. Okay, so we can say we have the LAN, we have the CAN, we have the MAN, we have the WAN. Okay, you can understand in future more. Okay, no problem. So we can say this is your LAN technology. This is another LAN. To connect multiple LAN, this is, for example, this is your internet, public network. Okay, internet. On the internet, what does IIG, ISP, NTTN, right? They are the service provider. Okay, so these are actually your public internet. To connect multiple sites, we can use the internet. Okay, but for example, if you connect two sites over the internet is a insecure media, because hackers are stay here. Okay, if you transmit or if you send any information from this PC to this PC after connecting through the internet, these data, when passing through the internet, hackers can stolen your data, right? So these are not safe. That's why we need a technology VPN. If we create a tunnel to connect multiple sites, this is called your VPN, virtual private network. And using the tunnel, if you send information, then hackers can see what is passing through the tunnel. Okay, now said. So after learning, not actually CCNA, after learning firewall or CCNP, you can learn about the VPN technology. Okay, CCNA, you can have a little bit knowledge on VPN. Okay, so when you learn, suppose this is the firewall. Okay, so every company use the firewall. So if you don't know how to configure firewall, how can you implement your VPN, right? You can't. If you don't know how to configure router, you can't. You have to learn the routing technology. You have to learn the firewall technology. You have to learn the switching technology. Also, you can have the VM, multiple VM or virtualization. So you have to learn the VMware. Also, you can have Windows Active Directory server here, who will actively connect it with the firewall. Okay, Active Directory is the user database. So you have to learn the Microsoft Active Directory. Okay, so you need to learn all. If you learn only CCNA, you can configure this network. No, because you don't have knowledge on CCNA, on firewall. You don't have knowledge that Windows Active Directory. You don't have knowledge on VMware virtualization. Okay, you can't do. And also on routing, CCNA, we have also routing, also switching, but these are the basic level. Okay, so you need to learn the more deeper level to configure this network, this type of network, like IIG network, ISP network, or any service provider network. Okay, you need to learn at least CCNP level routing and switching. Okay, so our topics in CCNA, then you can move for firewall, then you can move for CCNP, then you can move for CCI. Okay, so this is actually our enterprise network architecture or design. Okay, we need firewall, we need router or full layer switch, we need switch, we need access switch, and many more. You need to connect multiple sites. Okay, we need to learn the VPN technology, you need to learn the firewall technology, and many more. Okay, let's move for another topology. You can say this is a service provider network. Okay, actually we call it the MPLS network, multi-protocol level switching network. MPLS is on CCNP Enterprise. You can find these technologies on CCNP Enterprise or CCNP service provider, not in CCNA. Okay, so you can see this is your MPLS structure. Okay, why this network is used? Suppose you have a bank. Okay, ABC Bank. You have multiple branches inside the country, okay, or all over the country. Suppose one location in Canada, Toronto, another location in US, another office. Okay, you have multiple office in different location. Okay, so in this case, we will not use the VPN, virtual private network, because you need the dedicated circuit. Okay, because this guy is doing some transaction. Okay, he can use the ATM, okay, to send money or to receive to withdraw money. Okay, you need a high speed connection, and also which connection is you can depend on. Okay, so MPLS is more secured, and also your transaction will be faster than normal VPN. Okay, so you need to pay for MPLS network, because MPLS runs actually by IIG or ISP. They are the service provider. They will hire or they will rent it. Okay, you can buy the bandwidth or something like. Suppose you have multiple branch office, and through the MPLS network you can connect your multiple office like that. Okay, now your transaction will be smooth, and your data traffic will be securely communicate from multiple branches to multiple location. Okay, so if you want to learn more, suppose here you need to learn the MPLS, you need to learn the BGP, you need to learn the OSPF. Okay, many more routing protocols. These are advanced level. Okay, so this is actually our service provider network architecture. Then this one is your SD-WAN. Okay, software defined WAN technology. So on CCNP, there is separate section for SD-WAN technology. So modern network is using SD-WAN technology. It also used to connect multiple sites. It's like the VPN, like site to site. But on VPN, traditional VPN, you need to configure from each location. But using the SD-WAN technology or SDN technology, you can manage your multiple branches from the central location. Okay, so you can configure multiple sites centrally. You will get a central dashboard, and from the dashboard you can configure multiple sites. Okay, so this is the benefit of SDN or SD-WAN technology. SD-WAN is a part of SDN technology, software defined networking. This is the next generation WAN technology. Okay, and then Cisco ACI, we called it the next generation data center. It is also the SDN technology, software defined network. So if you do CCNP data center or CC data center, you can learn these technologies. Cisco ACI, application centric infrastructure. We are called it the next generation data center. Okay, software defined data center. Okay, this has a great demand. If you go in job sites, you can see they are asking for Cisco ACI knowledge, Cisco SD-WAN knowledge, because these are the next generation technologies. Okay, so before going that, you need to learn the CCNA, you need to learn the CCNP, then you can move for Cisco ACI, Cisco SD-WAN, and they have great demand. Okay, So this is a simple LAN technology. You can see simple LAN. You have the firewall, you have the switch. Okay, on the switch, multiple PCs are connected, and firewall is connected with the internet through the ISP, and they will get internet access securely. Okay, this is a simple topology. Okay, so these are the topologies. And now you can decide your decision. It will help you to take your decision, right? So let's move our actual section, OSI model. So our CCNA first section is OSI model. Okay, so I will show you the contents for CCNA. I'm going to show you CCNA syllabus. I will share you. So this is today our orientation class. So I will discuss everything about syllabus, contents, everything. Okay. You can see these are contents, fundamentals, day 1 and day 2, OSI layer, IPv4 subnetting, and ICMP. Okay. Day 1 and day 2. I will show you these parts. So OSI layer is very important because this is the first topics of CCNA. OSI means open system interconnection. Actually, we have 7 layers of model or architecture. You can say, suppose if you want to build a building, okay, then they need the foundation, right? They need foundation. Without foundation, you can't you can build up a building, right? Everywhere we need a design first. Okay, you can say OSI layer is the design of network. Okay, how traffic is passing from one device to another device. Okay, and how traffic is flow from one network inside a network. You can have a view on OSI layer. If you study OSI layer well, then you can have a view. Okay, then subnetting. Subnetting is another part because you need to all are IP-based communication, right? IP-based communication. So you need to learn how can we assign IP address on our PC. Okay, how can we make subnet? What are the IP range? Okay, how to write subnet, how to write broadcast, how to write subnet mask, broadcast address, what are everything you can learn when you do the IP version 4 subnetting. But we have another version, IPv6, IP version 6. Okay, I will also show you the latest one, IP version 6. I will also show you. Then ICMP, okay, L3 protocol. How ICMP works, why ICMP protocol is used. I will show you on day 1 and day 2. Then day 3 and day 4, first log into Cisco device. Okay, so suppose you have bought a new switch or new router, and now you need to do the configuration. Okay, how can access your switch for the first time? How can log in to the router in the first time? Okay, so you need to know. So I will show you from the basic. Suppose you have bought a new switch, and now you need to do the configuration. Okay, so I will show you from the scratch. No problem. So first log into Cisco device using command line interface. And these are actually the lab. Okay, these are the labs and also theoretical. Configure default gateway, basic configuration of Cisco L2 switch and router, secure remote access to Cisco device. What does it mean? Suppose this is your network. Okay, you are in home. How can you access to your router remotely and do some configuration? Okay, I will also show you. Suppose SSH or Telnet, you can log into the remote device and you can configure. Okay, how to configure L2 switch and router, I will show you. From basic. Backup and restore. You need to set the configuration, and if the configuration is removed or if the device is removed, you need to backup. Okay, so I will show you in this lab how to backup and restore a router or switch configuration, everything. Then our topics is VLAN, Ether channel, BTP, DHCP. So a lot of topics. So I will cover that actually in 20 classes. In 20 classes, I will cover. So we do not need actually 30 classes. I need 20 classes. Okay, to cover all. I will show. I will do 100% lab, also 100% concept. Okay, 100% lab and 100% concept on EV engine. No problem. I will show you everything from the S class. So today our topic is OSI layer. Okay, I will discuss this part today. The OSI model. Open system interconnection. OSI model. So in 1984, before 1984.
Hello?
Yeah.
Yeah, please, I have a question.
Yeah, sure.
How many hours per day?
Actually, per class will be 90 minutes. 90 minutes is
19.
enough. From my
Okay.
previous experience, 90 minutes is enough for a class.
Okay.
Okay, no problem.
Okay. I want
Okay,
to
so
align.
I will cover all. Okay, don't worry. If I need
O-
more classes, no problem. Okay,
Okay.
I am not super professional.
But we
I
are
will take
here.
extra class if you need. And also I have another opportunity. If you do vendor exam, I will provide remote remote support. Okay, just you need your setup on your room. Okay, I will show you some picture. Uh, According to the picture, you need to set up your lab. Okay, then I will remotely access, or my team will remotely access to your PC and do your exam. You will just you will just sit on the computer and acting you are a examining. Okay, and we will do the exam remotely and 100% pass. Okay, so on CCNA you can say you are a CCNA certified from now. Okay, no worries.
Okay.
I provide the remote support. So my many student has already passed CCNA. Any types of exam, I have the remote exam support. Okay, no problem.
Okay.
Okay.
Okay. Mm.
Any other question? Anyone have? I am going to start OSI model. Okay, so let's start. OSI model, which means Open System Interconnection. Okay, so in 1984, before 1984, what was the situation? Suppose this is your network. Okay, this is your network. On my network, I have the firewall, I have the switch, port switch, I have the access switch or distribution switch. Okay, but in previous, suppose if the firewall is in Cisco vendor, this should be Cisco. This should be Cisco also, because in different vendor they were not compatible. You cannot buy here the Palo Alto firewall and here the Cisco switch, here the Juniper switch. No. Before 1984, all the devices were not compatible. Not compatible. That's why the engineers have a meeting and they decided to invent something which will help you in a same network. They can use any vendor of device, no problem. Okay, they should be compatible. They should be compatible. Okay, that's why they have invented OSI model, a common architecture, and all the vendor like Cisco, Juniper, Palo Alto, they must follow the OSI model platform. Okay, or common architecture. As they follow the common architecture like OSI model, okay, now after 1984, you can use different vendor devices in your network, and now they are compatible. Okay, no problem at all. So this is the first reason why OSI model. Okay, then it helps understand networking, how to design a network, how to troubleshoot problems, learn protocols. Learn protocols. It will help you. If you have no knowledge, you can design your network. You can troubleshoot anything. You can understand network, how traffic flow from one network or one device to another device. Okay, you don't have any knowledge if you don't learn the OSI model. Without OSI model, networks would be complex. Troubleshooting would be difficult. Vendors would not follow common rules. Okay, and if they don't follow the common rules in your network, you can't use the different vendor devices. If you use the Cisco, all the devices should be Cisco. There are no possibilities to use another vendor firewall. But now we can use, because all the vendors are use the same 7-layer framework. So these are the reasons. Then we have 7 layers of architecture, 7 layers of OSI model. Okay, and in interview section, you should start from the bottom, not from the first. Okay, this is the rules. Layer 1 is your physical layer. Layer 2, data link layer. Layer 3, network layer. Layer 4, transport layer. Layer 5, session layer. Layer 6, presentation layer. Layer 7, application layer. So these are the 7-layer architecture. Okay, you should start from the bottom, not from the top. In interview question, if you start from here, you will be failed. Okay. So as a CCNA interviewer, they must ask what are the layers of OSI. Okay. And why OSI layer is important. This is the first question. And data transmission. Data transmission, this is the, for example, this is the sender. Sender means who sends packet or who sends data. This is the receiver. They are connected using a switch. Okay, this is the sender. From the sender side, traffic flow from top to bottom. On the receiver side, bottom to top. Receiver side, receive data. Sender side, send data. Okay. Application layer is the layer 7, right? All the layers are very important. I will discuss on each layer separately. Okay. Each layer has separate functionalities. Each layer has separate functionalities. I will discuss. Just for now, please memorize these one. Okay. Physical, data link, network layer, transport layer, session layer, presentation layer, and application layer. Now, this is the summary. Layer 7, we call the application layer, and it is used the key job or functionalities, user interface to network, user interface. Okay, I will discuss more. Just this is the summary. What is the task for each layer? Presentation layer responsible for format or encryption, data format or data encryption. Then layer 5, session layer used for control the session. Transport layer, reliable or fast delivery. Layer 3, network layer, the functionalities is IP routing, IP and routing. Then 2, data link layer are responsible for MAC and switching. Then finally, physical layer, cables and signals. Okay, these are actually the summary. We'll go for in deep level. First, we'll discuss from the application layer, because data flow happens from the top to bottom, right? That's why I'll discuss from the application layer. But when they're asking for which are the layers of OSI, then you should start from layer 1. First one is application layer. Okay, so application layer, we call it the, you can get the direct user interaction. Okay, something like you are browsing something. Okay, so you can see the effect. You are browsing something like facebook.com or google.com. When you type this, you can see this effect. That's why application layer is very closest to the user, right? Very closest to the user. You will get direct service. You can see the direct effect. So the application layer is the top layer. of OSI model, it interfaces directly with the end user. End user means you are using your laptop, you are using your desktop, you are using your mobile phone, and you can see something on your screen. And you are the end user. You are the end user. Okay. And provides network service to the application. So there are thousands of applications like Google is an application, Facebook is an application. Okay. So there are thousands of applications in networking. So you can learn more in future, no problem. Just for now, application means different type of service. Okay. Layer 7 is what the user sees. User sees. Like web browser, email client, you are mailing something, right? Or you can get a mail. Then file sharing, you are transferring a file from one PC to another PC. Okay. So layer 7 is what the user can see. Then layer 7 closest to the user, deals with the application protocols. Application protocol. Another important thing, what is protocol? Protocol. Protocol means how you can talk to each other or how we can talk to each other. Okay. How we can talk to each other. This is called protocol. Protocol is a type of media. Okay. Not actually media. Protocol is a or protocol helps you to communicate with each other. Protocol helps you to communicate with each other. We can have multiple devices. For example, switch, PC connected with the switch, connected with the router, connected with another switch, connected with PC. How this guy can communicate with each other or talk to each other? We need some protocol. Like for browsing something, we need protocol like HTTP or HTTPS. For email something or to send a mail, we need protocol. For example, SMTP, POP3. For file sharing, we need protocol like FTP protocol. Okay. Without protocol, you can do the file sharing. Without protocol, you can do the web browsing. Okay. On the background, protocol will help you. So we can say protocol defines how the devices can talk to each other or can communicate with each other. Okay. There are thousands of protocols in networking. Okay, you need to learn the behavior of each protocol. Behavior of each protocol. So most of the protocols are lies in the application layer, but protocols not only for application layer, other layers also we have protocols, different protocols. But almost 70% protocols lies on application layer. Okay. Ensure the application can communicate over the network. Okay. Protocols ensure our different applications can communicate over the network. Works with layer 6 presentation and layer 5. Okay. Layer 7, after layer 7, we have layer 6. Layer 6. Okay. It helps the layer 6 for next level of communication. The application layer helps layer 6, that means presentation layer, for next level communication. Then these are the protocols, common protocols of layer 7, you can see. And you should remember this port number. These are called the well-known port because you cannot change this port number. Scientists or engineers already fixed these port numbers for this specific service. You cannot change that service. Okay, you cannot change this protocol. That's why it is called a well-known port. Well-known port. HTTP, HTTPS, FTP, SMTP, POP3, DNS, DSCP, SNMP, Telnet, SSH. These are the protocols. HTTP is used for web browsing. HTTPS, secure web browsing. FTP, file transfer. SMTP, sending email. POP3 or IMAP, receiving mail. DNS, name of IP translation, DHCP auto IP assignment, SNMP network monitoring, Telnet remote command line, SSI secure remote access, and these are the port number. You can say port number 80 means it's a HTTP protocol. Port number 443 means it's the HTTPS protocol. Okay, so just memorize that. It will be clear more day by day. Okay, no problem. No worries. Every protocol you can understand. Okay, what are their activities? Why we will use this protocol? Just for now, just check. This protocol is used for what? These are the purpose and what are the port numbers. All are application layer protocol or layer 7 protocol. Then our second layer is presentation layer. Layer 6. Presentation layer, something presents. Actually, they are used for translate. Application layer works with pure data. Application layer. When it comes to presentation layer, these data should be formatted. Like it will be compressed. This data will be compressed. These data will be encrypted. These data will be converted into PDF format or something like. This conversion or formation is happened on presentation layer. Presentation layer is responsible for data formats, encryption, compress. Compress means zip, unzip. Encrypt means, suppose my name is Ashish. You can see this clear text. But if I write something like, okay, you can understand what this one. Just for symbol. Okay. So this is called encryption. Encryption means plain text converted into cipher text or unreadable format. Unreadable format for security reason. Okay, this is called encryption. Encryption is also happened on presentation layer. Data formats, this is our Word file. This Word file, you can make it PDF conversion, right? This is called data formation. And compress, you can zip or unzip any file. Okay, so these three types of words happens on presentation layer. When data comes into presentation layer do these works. Make sure layer 7 application can understand the data. Works between application and session layer. Because presentation layer is here, presentation, then session layer. Presentation layer is between application layer and session layer. Often invisible to users, right? So presentation layer cannot be visible by the users. Actually, only application layer user can see something, other layers cannot be seen. What happened? Never. Only the application layer you can something like visible. Other layers you have to conceive something is happening. Okay, you can see what is happening inside the network. Okay, except application layer. So layer 7, what the user sees. Layer 6, how the data is prepared and secured for the application. So they need data formation, encryption, and compression to make the secured traffic. Okay, this is the activities of layer 6 or presentation layer. And these are the protocols of presentation layer. SSL TLS. Okay, so these are the protocols. You don't need to explain these one. You just remember these protocols, because as long as you are be a network engineer, you can learn on every protocol behavior in future. Okay, so just for these protocols, what are their use, you need to learn. SSL and TLS used for encryption for secure web traffic. encryption for secure web traffic. JPEG, GIF, PNG, these are actually data formation, right? Or image format. These are our image format, image file format. GIF image or PNG image or JPEG image format encoding. MPEG or MP3, audio video encoding, right? Audio video encoding. ASCII and EBCDIC is the character encoding. MIM, email attachment formatting. Okay, so these are the presentation layer protocols. Then our session layer. Okay, session layer is layer 5. Session layer actually manages the session or manages the conversation between computers. One computer is communicating with another computer. Okay, suppose I am talking with you over a phone. Okay, so when I start the session, then what is the duration of the session? Then at the end, I need to cut the session, right? So this is actually one type of session. Session means manager of conversation. Manager of conversation. In the OSI layer, session layer is responsible for establishing the session, managing the session, and terminating the session. This guy wants to communicate with this one. So when session starts, when session ends, and what is the duration of session, this will maintained by the session layer. You can say session layer is the manager of the conversation. Another example, suppose facebook.com. You are not the only guy, you are using the Facebook, right? So there are million people are using the Facebook at a time. They are using the Facebook. Okay. So if session layer is not handle the session, then multiple users can't use the Facebook at the same time, because session layer will help you to create multiple session for each user or every user. Okay, create the session for all users, and now all are using the Facebook at the same time. Okay, so this is a real life example of session layer. Its basic task is establishing, managing, and terminating the session. Provides dialog control, session maintenance, and synchronization. Works between presentation and transport layer. So next layer is transport layer, and this one is session layer. Before the session layer, we have the presentation layer, right? So session layer works between presentation and transport layer. Often invisible to the user. We can also can't see the session layer, but critical for stable communication. Because if you don't have manager in your company, okay, the activities will be randomly, right? Will be not in well organized. So you need manager. Under the manager, you need to work, right? Then all the works will be perfectly done. Same thing like session layer is the manager of the OSI layer. It will manage all the communication between different devices. Okay, already discussed this one. Key functions of the session layer. Session establishment. Open a session or connection between two devices or applications. When you log into the remote server using SSH or Telnet, okay, it will also help to create a session. SSH and Telnet, these two tools are used for remote access to the device. How? For example, in your network, office network, you have a rack. On the rack, you have router, you have firewall, you have switch. Your in different location. For example, your network is in USA, you are now in Canada. Okay, but now you need to do something, or you need to do some configuration on the firewall or the router, but you are not on the office. Okay, now you need to, from your computer via the internet, you need to log into the remote device, log into the router or firewall remotely. Okay, in that case, you can use the SSH or telnet. SSH or telnet. These two protocol will help you how to access on the devices remotely. Okay, so I will do separate lab for these two, SSH and telnet. Then you can understand in future. Okay, so these two tools are useful for remote access to the remote devices. Then session management. Session management means it will help you to organized and synchronized manner. Like as a manager, under manager, a lot of executive. Okay, if you don't have manager, the executive will do works randomly. Okay, your task will never end it. Okay, they will be not well organized. Managers will help you so that each engineer or executive work properly in organized way, in a synchronized manner, right? Something like session termination. Okay, when the task is have done, then it will help to terminate the session. And dialogue control. Dialogue control means three types of communication. Controls: simplex, half duplex, full duplex communication. Okay, our communication can be simplex, can be half duplex, can be full duplex. Simplex means one-way communication. That means if you have a road, this is a road, and all the cars and vehicles are in a one direction, unidirection. That means one-way communication. Half duplex is also the alternative of simplex. Alternative of simplex. Half duplex is also the one-way communication. One-way communication. But now, today's world, our communication is all the full duplex. Full duplex means two-way roads. One part is this direction, another part, all the vehicles are in this direction. Okay, this direction and this direction, both way direction in a road. Okay, we call it the full duplex mode. Full duplex mode. Okay, now all the switches works in full duplex mode, not half duplex. Half duplex are not used. Unidirection is not used nowadays. All the communication is full duplex. So it will also maintain by the session layer. Dialogue control. These are the protocols of session layer. NetBIOS, session service for Windows networks. Session services for Windows network internally works. You don't need to configure these ones. RPC, remote procedure call. Communication between application, voice application. SQL, database session. TPTP and L2 layer 2 tunneling protocol. These are actually used in our VPN session. VPN session management. These two protocols will help. SMTP, messaging session. Messaging the session. Okay, these are the protocols you can see in future, but just for now, remember this protocol.
Hello?
Hello?
Yes, please, could you explain PPTP protocol again, please?
Point-to-point tunneling protocol, layer 2 tunneling protocol.
Okay.
Okay, in future, you can see this in future. That means it will use for, when we create the PPTP and layer 2 tunneling protocol or VPN. Okay, they are using, when we configure VPN, they can use the PPTP or layer 2 tunneling protocol for VPN session. VPN is
Okay.
virtual private network. But nowadays IPsec VPN is used. IPsec protocol is used. Okay, PPTP and layer 2 tunneling protocol is rarely used. But to connect multiple sites, we are using the IPsec or SSL protocol. to configure VPN. But please remember these are also the protocol, but I will theoretically explain these two. Okay, no problem. Then our next one is transport layer. Layer 4 is transport layer. This one is very important layer. And again, I am coming to the previous slide. Upper 3 layers works with data. Please remember, upper 3 layers works with data. Okay, application layer works with data, presentation layer, data formation, session layer for creating the session for the data, right? But lower 4 layers, these are our network layers. Actually, how data can communicate between device to device, they will be responsible. Their activities are to communicate the data between devices, between host, or between network. These are called the network part. These are our data communication part. How data can communicate, they will define. Transport layer, network layer, data link layer, and physical layer. Okay. So today our last topics is transport layer. Okay. Today our last topics. Then our rest of the topics will be in another day. So layer 4, transport layer. Transport layer is what? It ensures reliable or faster delivery data between devices. They will ensure the data deliveries securely and faster delivery. Okay, transport layer is responsible for data communication. End-to-end connection, ports, sequence numbers, and acknowledgement. I will explain every part. Wait a bit. End-to-end communication. I will explain that. Using ports. Ports are where? Ports are on application layer, right? On application layer, we have different ports like HTTP ports, HTTPS port, SMTP port, okay, FTP port. So ports means services. Ports means services. Their ports are on application layer, but they are to communicate multiple to communicate between multiple or two hosts. Transport layer is responsible. Application layer refers to the service, but this service transmitted by transport layer. That's why using ports and sequence numbers and acknowledgements, they will provide end-to-end communication. That means the services or data delivery should be follow a sequence number, should be acknowledged, and many more. Okay, I will explain every section. Wait a bit. Provides end-to-end communication, uses ports for application identification. So transport layer should know what are the services I need to transmit, right? Transport layer should know what are the services. Services defines inside the ports, and ports are on application layer. For example, telnet service. Telnet service. Port number is 23. Transport layer should know what type of service I need to transmit, right? That's why uses ports for application identification. Ensures reliable with TCP. Okay, I will explain that. So on transport layer, we have two protocol, UDP, TCP and UDP. TCP and UDP. Transmission control protocol, user datagram protocol. On transport layer, we have two protocols, TCP and UDP. Or you can say service category. Service category. All the services are ports are on application layer, right? On application layer. But they can be, for example, on application layer, or layer 7, we have the port number 20, 23, port number 20, port number 80, port number 443, port number 53. Okay, so they are different service. 23 means telnet, 22 means SSAs, 80 means HTTP, 443 means HTTPS, 53 means DNS. These are the port and protocols of application layer, but they can be categorized either TCP or UDP. For example, port number 23, telnet, is a TCP port, category of TCP. 22 is the category of TCP. Port number 80, also the category of TCP. DNS 53, the category of UDP. Okay. Application layer service can be either TCP or can be either UDP. Transport layer will send the TCP packets or UDP packets. Transport layer will send TCP packets or UDP packets. Okay. So let's classify what are the TCP and UDP. What is TCP and UDP? TCP and UDP. Not this one. Okay, this you will find. TCP. TCP is the connection oriented protocol. Connection oriented. UDP connectionless. That means no guaranteed. No guaranteed. UDP. Not guaranteed. TCP is more guaranteed. Okay, suppose this host will send data. This host will send data to this one in a connection oriented way, or can, and this should be guaranteed. That means if this guy send a packet, this guy will surely get this packet, should get this packet, if it is TCP communication. But if it is UDP, maybe or may not. Packet can be reached to this guy, can be or may not. No guaranteed. Not a guaranteed protocol. UDP is not guaranteed, TCP is more guaranteed. Okay. TCP is reliable. UDP never reliable. Never reliable. Reliable, ordered, error checked. UDP, fast, low overhead, no reliability. But TCP is slow. TCP is slow. UDP is faster because some characteristics. I am going to discuss this character. TCP, first one is end-to-end connection. End-to-end, yeah.
Sir, what is the meaning of this connection-oriented?
I am explaining.
Okay.
Connection-oriented means end-to-end connection. Actually, they will make a three-way handshake. Three-way handshake. Three-way handshake. Like this guy wants to communicate with this guy. Okay, I am simply explaining, then we'll go the deeper. So this guy will send a hello message. Suppose I am making a conversation with you over a phone. Okay, so I am sending first hello message, right? Hello, are you here? Then if you send me hello, then our conversation begins. But if you never send hello, I will not start talking, right? I will not start talking. Suppose if not happen, that means I am calling you without your hello, I am starting speaking. Okay, it's like UDP. It's like UDP. As soon as call you, I am starting hello. Either you heard or not. Either you can listen or not. Okay, this is UDP like. And connection oriented or three-way handshake or end-to-end connection means first I will send you a hello, if you are alive or not. Then if you are present, you will send me a hello. Yes, I am here. Then I will start communication, right? This is like connection oriented. That means we are sure from the both parties that we are present on phone conversation. Okay, this is like connection oriented. Okay, so when these two guys wants communication, then this guy will send first hello message. Hello message. And this guy will also send hello, hello and acknowledgement. 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 Acknowledgement means something like I am also here. Okay. And this guy still not send acknowledgement. Only send hello. Okay. But this guy also send hello and acknowledgement. So this one will send acknowledgement. Acknowledgement. Okay. This is a step 1. This one is a step 2. This one is a step 3. That's why it is called the three-way handshake. Three-way handshake. After this three-way handshake happened, they can communicate with each other. They can securely transfer data. Okay, that's why it is called the connection oriented. But UDP never maintain these rules, never follow the three-way handshake mechanism. That's why it is called the connectionless. Okay. TCP also maintains the flow control. Flow control. Flow control. What is flow control? Suppose this is a user and this is another user. This guy will send data to this one. So everyone, each guy has a buffer, right? Where data will be stored. This one also a buffer. And now this buffer size is, for example, 4 MB. 4 MB. And this one, for example, 8 MB. 8 MB. Now this guy, if sends 8 MB packets to this one, data will be overflow, right? Data will be overflowed. That's why TCP maintains the flow control using a mechanism. Two mechanisms. One is flow control using windowing. Sorry, can't write here. Windowing. So I am writing here it another, yeah, oh no. Actually, this is not a session topics. Okay, the deeper level, because this is for computer science graduate. They already learned this technology. So I am simply explaining this one. So for example, flow control. Okay, so this is the buffer size 8 MB and this buffer size is 4 MB. And if this guy sent 4 MB, okay, 4 MB data, then this guy cannot accept because its buffer size is low. Okay, so this is, and TCP flows TCP has the mechanism to maintain the flow control. That means what the receiver can receive, this guy will send same amount of data. Okay, that's why TCP maintains the flow control. But UDP never. Another one is sequencing. TCP maintains the sequence, UDP never. What does sequence means? Sequence means, so they are sending actually bit, right? Data means computer only understand the bit. Suppose this guy sends this one. Okay. If the TCP, then it will send in a sequence. But UDP, it will maintain no sequence at all. And also TCP has the error recovery. Error recovery. For example, this guy sends this data, this guy receives 1110101. So this bit is missing, right? This bit is error. So TCP has the error recovery option. Data link layer will check the error, and TCP on transport layer will ask the sender to resend this one. They have the mechanism to check the error and error recovery. Okay. And then this guy will send the error bit, and this guy will now get actual bit. This is called error recovery. Okay. So TCP has the error recovery mechanism, but UDP doesn't have. Okay. So TCP maintains actually three-way handshake. That means connection oriented, flow control, then sequence, then error recovery or error recovery. Okay. That's why it is slow. But UDP never follows these rules. As soon as he gets the destination MAC address or IP address, he will send data. UDP has no knowledge about three-way handshake, no flow control, no sequencing, no error recovery. Okay, that's why UDP is faster, TCP is slow. TCP is connection, TCP is error-free, 100% connection-oriented. UDP is never error-free. Okay. These are the difference between TCP and UDP. Then, so you can see these are the TCP protocols, but they are application layer protocol, right? They are application layer protocol. So transport layer gives services for application layer. Transport layer gives services for application layer. How they can communicate, right? How they can communicate. TCP and UDP. So UDP is used actually for video and voice and video conferencing, because in voice communication, there are no packet can be jitter. Okay. So in voice, jitter cannot be accepted. Jitter means delay. So suppose one device, you are opening a video conferencing. Now, if it is slow, so it is not accepted for video and voice. Okay. Suppose first coming the voice, then coming the video. Okay. They are not synchronized. If you need the TCP protocol, okay, if you use the TCP protocol, then you need to maintain the flow control, you need to maintain the sequence number, you need to maintain the error recovery, and they need huge time, right? Or a huge delay. Delay will be. But in type of voice and video conferencing, delay is not accepted. That's why engineers already says UDP protocol for video streaming or voice communication. Right? In case of voice or video or telecommunication, we use the UDP protocol, not TCP actually. These are the real example of UDP. Okay, TCP actually we are using a web browsing, then downloading a file, then we are telnetting or SSH something to access to the remote device. Okay, and many more. Okay, so today we will stop now, and tomorrow we can start rest of the part. Okay, so as of now, if you have any question up to now.